5G technology is here. How do you see 5G affecting the fixed network?
Well, first of all, everybody thinks 5G is sort of new radio standard. It's much more. It defines a whole new end-to-end network. Well, me coming more from the connectivity and optical space, I might even say, you know what, it's an optical network with an antenna at the end. Some might say, no, it's about critical infrastructures, it's about 10 times lower latency, it's about 10 times more reliability, and. Now, if you look at the different use cases, the industry defines basically 3 use cases. One is enhanced mobile broadband, that's access for everybody with much higher peak data rates. The next one is massive type of IoT. So lots of different sensors, an infinite amount of different sensors, the massive machine type application. And the other one is ultra-reliable low latency applications. As an example, this could be factory automation or this could be the connected car. All of which are somehow applications within 5G and will drive the network.
And how does the fixed network come into play there?
Well, if we use those examples I was just talking about, for example, thinking about the ultra-reliable low latency application, it obviously needs low latency. To give you some examples, a connected car, looking at road safety in cities or even outside cities, probably requires a latency of around about 10 milliseconds or faster, end-to-end. So taking some data, going through the network, doing something with it, going back to that car, 10 milliseconds. Another one which is very restricted is everything which is factory automation. So you can see doing things with robots and so on, probably much less than 10 milliseconds, end-to-end latency. So one thing is very strict latency requirements. Another one is synchronization requirements. So in order to do things like, for example, carrier aggregation, we have end-to-end synchronization requirements of 130 nanoseconds and better in timing error. This is very difficult to achieve, both of it. The latency and the synchronization requirements will require a fundamental change of the network. It's not just adding an antenna at the end of it, it's really changing the whole network with it. But another one I want to say is we obviously want to look at deploying all these different applications over one single fixed or backhaul network. So that requires technology which we call network slicing, using the same network for these different applications, which is not easy. So you got the very low latency one or the sync sensitive one, as well as the high data, getting gigabits to everybody one.
And what needs to happen at the network edge for 5G or for those use cases to realize their potential?
I think at the end of the day, what will happen at the network edge is, first of all, we will see data centers being distributed to the edge. Now that is a very high level saying. If I go back to the low latency and synchronization requirements, specifically the latency requirements or aggregation requirements of massive machine type of applications, what you see there is these things being processed very near to the user at the edge. So provide some compute, do some, as I said, processing, aggregation, something with it very near to the user, and then going back into the network. There are other applications which might not require that. So what we will see at the edge is much more than just some transmission, some fibers, some radios. So there will be some small data centers in boxes coupled with transmission, enabling those functions of low latency, of first type of aggregation, and so on.